This video takes off from the previous one on indices. To see that, just click on the link at the top right corner of your screen. Here are the laws of indices. I omitted one in the previous video, this particular one. X raised to the power of a bracket b equals x raised to the power of ab. So I've included that in this video. The next thing is going to be to rely on these laws as we did in the previous video to simplify a number of problems. So here we have examples. We are going to be simplifying all of these problems. So I'm just going to write simplify. The first one is b raised to the power of -3 divided by, looking at the problem here, we've got the same base and the division. So we would see here that law 2 is going to be most useful because we've got the same base and the division. So first we need to recognize that this b has a power of 1. So we are just going to subtract 1 from -3. So this is b -3. Then the division changes to a minus, then 1. So this is b raised to the power of -4. So here I can apply the third law that has a negative index, and this is going to be equal to 1 over b raised to the power of 4. Because here we have that x raised to the power of -a equals 1 over x raised to the power of a. So this is the final answer. Second, x raised to the power of 7, then a -5. Looking at these and across all of the rules, we would find that this particular problem aligns closely with law 6 because we've got two powers, one inside and one outside. So this is just going to be x raised to the power of 7 times -5 because we've got a product of a and b here. So this is x raised to the power of -35, and I can as well apply law 3, and this gives 1 over x raised to the power of 35. This is looking good. Question 3, we've got 15p raised to the power of 3 divided by 3p raised to the power of -2. Now looking at this, we would see that we've got p and p on either sides of the division sign. So it looks as though the second law is going to work. But here is a stumbling block. The numbers here cannot be written as the same base. So I could just, to make it easy for me, I can just rewrite this as 15p raised to the power of 3, then use this symbol that's divided by 3p raised to the power of -2. So with these, I can cut because I know that 3 can reduce 3 once and it can reduce 15 5 times. And since this is a division sign, I can rely on the second law right here. So this is at the top, I've got 5p. So since this is a division sign, so this looks like x raised to the power of a divided by x raised to the power of b. So this is going to be p cubed. Then since this is going to be x raised to the power of a minus b, then the division practically changes to a minus. Then I've got a -2 below. So this is -2. So this is 5p raised to the power of 3 plus 2. This is 5p raised to the power of 5. This is my final answer. Question 4. We've got 4x all cubed times 3x all squared. Now, because the bases are not the same here practically, it's going to be impossible for us to use the first law outrightly. So what we are going to do here is to realize that these powers here affect both items. So this right here, 4x all cubed, is going to be written as 4 cubed x cubed, going by this law, law 5. Similarly, 3x all squared would be 3 squared x squared. So right here we know that 4 cubed is 4 times 4 times 4, that's 64. Then x cubed times 3 squared is 9. Then we've got x squared. The next thing is to realize that 64x cubed is 64 times x cubed, and 9x squared is 9 times x squared. So I can just like rearrange. So this is gonna be 64 times 9 times x cubed times x squared. 64 times 9 is 576 times. So we can see here that the bases are the same. So we are just going to add the powers. So the x cubed times x squared will be x raised to the power of 3 plus 2. So this is going to give 576 x raised to the power of 5. Okay, we're going to take the next one, question 5. We have to simplify 14x raised to the power of 3 over 2 divided by 7x raised to the power of half. As we can see here, we've got the same bases, x and x, but when it concerns the numbers, the bases are not the same. There is no way 14 and 7 can be written as a number in the same base, practically. So what I'm just going to do here is to rewrite this 14x raised to the power of 3 over 2, then use this division sign, 7x raised to the power of 1 half. Now I know that 7 can reduce 14, so this is 7 here 1, 7 in 14 is 2, and since the bases are the same here, in x raised to the power of 3 over 2 and x raised to the power of 1 half, and I've got the division, I can rely on law 2, so I've got a 2 here, so this is x raised to the power of 3 over 2, the division changes to a negative sign, then I've got 1 half, so this is 2x. Now 3 over 2 minus 1 half, since the denominators are the same, so this is just 3 minus 1 over 2. This is 2x, 3 minus 1 is 2, this is 2 over 2, this is 2x raised to the power of 1, and my final answer is 2x. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up, share to your friends and colleagues on social media. Don't forget to drop a comment and click on the subscribed icon. To get notified when I upload new videos, kindly click on the all, that's the dark bell button on the subscribed icon. Thank you for seeing it once again. See you in the next video.